Hello and welcome to my YouTube channel and R.S.Academy. I am Navdeep and I'm back again by taking 11th part of chapter structure of atom that is belongs to class 11. So in this part we will discuss about the limitations of Bohr model of atom. So whenever we talk about the Rutherford model of atom, so in Bohr model of atom we will discuss lot more concepts that we have already studied in our previous parts of the video, and here we have the limitations why it could not able to explain some phenomena. Very first limitation is that is it fails to explain the spectrum of other atoms having double electrons like as helium, like as lithium plus, like as beryllium 2 plus. So all the atoms having two electrons, how they don't form the spectrum, it could not explain that one. Second is what? This theory was unable to explain the splitting of spectral lines, as we discussed earlier, that the spectral lines having some gap between them, like this one. So why the splitting of spectral lines in the presence of magnetic field means whenever we talk about the splitting of magnetic field lines, splitting of spectral lines in terms of magnetic field, that is called as Zeeman effect, as well as in an electric field, that is called as what? The Stark effect. So this theory could not able to explain that phenomena also. The third limitation is it could not explain the ability of the atoms to form the molecules. It could not explain how the atoms will form the compound by chemical bonds. So this is all about the limitations of Bohr model of atom. Now next on we move on the next model of atom, that is called as what? Quantum mechanical model of atom, which is somewhat more classified or somewhat more elaborated form of the atomic model. Now, before when we move on this model of atom, we need to talk about the two terms or the two phenomena, that is what dual behavior of matter and the Heisenberg uncertainty principle. So these two concepts uh, perform a crucial role for explaining this model of atom. So the very first is dual behavior of matter, as we discussed earlier, that the radiation also consisting of the dual nature, that is what? The wavelength nature or particle nature. The similar way matter also exists in two forms or can show the two nature, that is what? The wave nature or the particle nature. So the dual behavior of matter is defined by the French physicist named as what? Louis de Broglie in 1924. He proposed that matter exhibits dual behavior like as radiation. Means, as I told you, as radiation shows the dual behavior, in a similar way matter also exhibits its dual behavior, that is the particle as well as the wave nature. Means the matter also behave like a particle as well as wave. It means that like a photon, the electrons also have momentum, that is momentum P is equals to mv, as well as the wavelength, that is lambda, right? So if we talk about the two terms, that is what? The momentum and the wavelength. So these two terms are related with the particle nature of matter, and the phenomena like as diffraction, interference, polarization also exhibit the wave nature of particle. So this is what the dual behavior of a particle. In a similar way, when he was explaining this dual behavior or de Broglie equation, so he has derived de Broglie equation. So the de Broglie equation is known as what? As we have discussed earlier, according to Albert Einstein, that is the energy and the mass are related as E is equals to mc square. This is the relation between energy and the mass of a particle, that is related as E equals to mc square. Or and if we talk about for a photon, so E is equals to h nu. The nu is what? frequency, as you know. So in terms of photon, E is equals to h nu, and in terms of particle or matter, is equals to mc square. When we compare these two equations, so we got as what mc square, that is equals to this one, is equals to h nu, that is equals to, because both energy are same. So if we compare, if we equate these two energies, we get as what mc square equals to h nu. So if we just take this one, that is mc square equals to h nu, and nu is c by lambda, as we discussed earlier, that is nu equals to c by lambda. So if one c is cancelled out and we first find out the lambda, so we can say mc is equals to h by lambda. In this way we can say lambda is equals to h upon mc, where c is what speed of light. If we just replace the speed of light, here we can say mc, which is called as what the momentum. So lambda is equals to h by mc, and mc is equals to what the momentum of the particle. In a similar way, momentum is equals by p, or we can say the lambda equals to h by p, or if you just replace this c by v, normal velocity of an particle, so we can say lambda, that is wavelength, is equals to h upon mv, where mv is what the momentum of particle, momentum of particle or any matter. So this is the de Broglie equation, that is h is equals to h upon mv. Okay, so this is what de Broglie equation, which is derived by the de Broglie to tell about the particle nature of matter. This is what. Okay, so this is what the 11th part. We will thank you. If you like, share and comment, and subscribe my channel for latest update. Thank you.